All right. So we have these two couples, or we have this couple, and they're in different departments, and so there's different averages to compare against. So how can we tell who did better relative to their particular department? A z-score, very good. So we want to match them up according to a z-score. And if you turn over to, I think, page 9 or 10 in your packet, it starts the next set of slides. It also has the answer here. So the z-score that we had gotten for the husband was what? 1.5, good. And then for the wife, 1.25. So even though she makes a better grade, the husband is actually higher up in his respective department. Okay? So the next thing that we want to do today is see, okay, so let's relate that now to a percentage. Let's get that in terms of the percentage of his department that he is better than. Okay, let's see actually what percentage that department is. And so we're going to do that with our z-charts, and that is located in your pink packet, your resource packet that you guys got. So go ahead and pull that out, and I want to talk you through this resource packet and your z-chart. So when you open up your resource packet, the first two pages are a formula chart, which we haven't gotten to yet. The next page, front and back, is this z-chart. So this z-chart will tell us the area below a particular z-score. So, for example, on this side, what would the z-score be for the mean? How many standard deviations away from the mean is the mean? 0, good. So our z-score for the mean is always 0. Okay, let me put that back up there. So z-score for the mean is always 0. And what you should notice on this page is that one side has got negative z-scores because all of these z-scores are located where on the curve? If they are negative z-scores, where are they? Below the mean. Very good. So this side of the chart is z-scores below the mean. Hence, all the percentages that are below, once you pick a particular z-score and you want to find that area below it, can you tell me how those, well, tell me first, what would the area below the mean be? 50%. Okay. So all of these ones on this page that are located over here on the left-hand side would be areas that are how much? Less than 50%. Good. So we know all the areas on this side are going to be less than 50%. If you take a look down here at the bottom, you can see that the biggest number on this side is 0.50, which is 50%. Okay? Now, so for these numbers, it's kind of like a stem and leaf, where here you've got a whole number in the 10th spot, and then these numbers across are the hundredths spot. So if I wanted to find the number negative 2.45, I would go to negative 2.4, and then I would go across here to the 500th spot, and that would be the area below that z-score. Okay? So over on the side and the top are the z-scores. All of these numbers here in between are the areas below a particular z-score. Okay, the areas below a particular z-score. It's important that you know they are below, because sometimes you will ask for what's above it. Well, it's not these answers. Okay, it's the opposite of them. All right, now if you turn the page to the back of the chart, then you will notice these z-scores are all what? All of these z-scores are positive, and so the smallest area on this page is the 50%. That is the mean, a z-score of 0. All of these z-scores are positive, so all of their areas will be what compared to 50%? Above 50%, greater than 50%. Okay. All right, so let's go with that problem about the husband. Let's see what percentage of people in his department he's got a higher salary than. So we're going to find what z-score? 1.5, and it is a 0, so 1.50 is our hundredths place. So 1.50 is a z-score of, an area of 0.9332. And I actually have that on a slide on your page. You can see there at that intersection of 1.5 and 0 is this number, and that means he's in the 93rd percentile. So in context of this problem, like having to do with salaries and stuff, can you tell me, think about what that means. I want you to think about what this means in terms of this problem about salaries. Okay, think about that in your head. I'm going to have you tell your neighbor what it means in a second. Okay, so tell your neighbor what that 93% means for the husband. In context of this problem, what do you think? He's in the 93rd percentile. So what do you think? Perfect. Okay, good. So he's in the 93rd percentile. So did you tell your neighbor? That means that he earns more than 93% of his peers, okay, or 93% of the people in his department. Okay, so him being in the 93rd percentile. Okay, very good. The next question is about the wife. She has a z-score of 1.25. Well, I want to know what percent of the department has a salary better than hers. That means higher salary than hers. So we want to go to find her amount on the z-chart, 1.25, so find that one. Okay, so 0.8944. So do 89.44% of the people score higher than her or make more than her? No. Well, what is it? That's what's lower than her. So to get what's higher than her, I have to do what? Good. Subtract it from 1. So here's a way you would write this, and we're going to get into this notation here. The probability, or the percent, of z-scores greater than that 1.25 equals, the whole 100% minus that lower part. So 10.56% of the people have a higher salary than she does. Okay, that's where that comes from. So just this upper part, 10.56. All right, very good. So now what I want you to do is this little quick check, and I'm going to give you some time, and then I'm going to come around and stamp you for your pages 6 through 8 while you are doing that. It's going to be a quick stamp. I'm not going to stamp your pink sheet or the front. Just going to check and see that you did it, and we'll go on. But I want to do this first problem with you. So in your packet, in your notes on page 10 or something, I don't know, so you have to go past, so page 9, at the bottom corner of page 9 is this slide, and then on the top of page 10, you've got a whole bunch of little normal models. So I'll leave this up here, but I'm going to do the first one with you. So the directions say, for each of the following problems, draw a quick sketch and label the areas. Use the correct notation, so I'll explain what that is, and find the probability. So the first question says, find the percent below the z-score of 2.13. So here's what that looks like. Let's see here. So you all have got a normal model on the next page. Let me find where it says number 1. So let's label, our z-score of 0 is in the middle, and then we got 1, 2, 3, and so on. So for this problem, we are to find, and so here's the notation, the probability that you get a z-score less than 2.13. So that is how that is written out, the notation that is used for that. And so then I'm going to come over here and I'm going to draw my z-score on here, and I'm going to label it. Okay. Now, what area do I want? What is the shaded section I'm going for? This area below. Good. So you can come in here and you can shade in this area that you were going for below that 2.13. And so now we're going to go find that answer. And how are we going to get that area below? We're going to go to our z-chart to 2.13. So let's go find it. 2.13 is 0.9834. So therefore our answer is 0.9834. I do not mind at this point how you write it, as a decimal or a percentage or even a fraction. In fact, actually all year long, percents, decimals, fractions are interchangeable. Totally interchangeable. There's not a requirement on the format that you put your answer in. So you just got to get used to knowing how to go back and forth between those. Okay, very good. So I want you, and I'll leave this slide up here so that you can have easy access to the problems you're doing. Do the rest of these 5, numbers 2 through 6, on that quick check, and I'll come around and stamp you while you're working. You want to talk to me real quick about finding the area in between those two amounts? How can I do that? Yeah, we're going to have to subtract. So what do we need to get first? You cannot go 2.6 minus 1.6, and that's 1, and find the area below 1, or whatever. No. Don't subtract the z-scores, subtract the areas. So come here and find that area below 2.6, and once you find that area below 2.6, then what are you going to subtract? So for me, I think, is this right? 0.9953 is that entire shaded green area. Is that correct? Okay, so I'm just going from memory. All right, so that entire area below 2.6 is 0.9953, and then I'm going to subtract off all this section here below 1.6, which is 0.9452. So when I subtract off that lower area, I get 0.0501. So 5.01% is what is left there in between. Okay, so that's what you always have to do when you have subtraction. All right, so let's check those real quick. Let's see here. Okay. All right, so there is 1, 2, and 3. Number 1 we did together. Number 2 was 1.5% or 0.015. Number 3 was 0.90. What is that? 0.90 what? I can't read it. 0.9049. Okay. All right, and then when we came to number 4, it was that area above, so you were subtracting from 1, and so that was 0.1635. Number 5 we just did, where you subtracted 0.0501, and then also number 6 you subtracted as well and got 0.8562. Okay, 0.8562. Now, that chart, those numbers on that chart come from a person doing calculus and doing calculus for that function and coming up with all those numbers. Well, we just read the chart so that we don't have to do that calculus. All right, any questions on those quick check problems? Okay, so then we're going to do a couple more type of questions to give you, to kind of go a different way. So let's go back to the notes. So on your next slide that you have there, I think on page 9 or so, we're wondering, first, what would the wife need to earn the same amount as, to be the same position as the husband? So to be the same position as the husband and to match his relative position, what do I need to happen? I need her z-score to be 1.5 and get her new x value. Okay, so I need to turn that z-score into 1.5, so we come down here and you end up with that. So with her mean and her standard deviation, make her be in the 93rd percentile and solve for her new x. All right? I'm not going to do the math there, but algebraically, what would you do first? Multiply by 1.8 on both sides and then add that 13.5 over. Okay? Moving on. So what if we wanted the husband to earn in the 95th percentile? He's in the 93rd percentile, but he wants to be in the top 5%. If he wants to be in the top 5%, he has 95% below him. Okay? So I want to find top 5%, 95% below him. Where on this z-chart is the area below him? Is it on the sides? Are these numbers over here have to do with the area below him, so I need to find 0.95? Okay, and here's my question. Do I need to find 0.95? Or do I need to find a number inside here? Okay, which one of those two things you think? Numbers on the side or numbers in the middle if it's 95th percentile? 0.95 in the middle in this section, because this is the area below. All of these are the area below, so these are the percentiles. So I'm going to come down here and I'm going to find the closest one to 95%, and that's right here. There's actually another one that's on the other side of it, but I'll let you go either way. So here, the z-score then that corresponds is 1.65. So his z-score needs to be 1.65 in order to be in that 95th percentile. So then we can go back and say, oh, I need his z-score to be 1.65. So let's find what his salary needs to be. And so that's finding that salary. Now we're going to do more of those kinds of problems tomorrow, but I did just kind of want to give you a little inkling of that today, as well as do these other quick check problems. So you guys have got those also on your little slides there. Let's go through these, and then I'm going to have you do your assignment, which the assignment is pages 12 through 14, just the first 11. And I'll start you on that after we do these. Okay, so here, the Beanstalk Club is limited to women and men who are very tall. If the women's heights have an average of 63.6 and a standard deviation of 2.5, find the cutoff heights for the following chapters. So, first thing I want you to know is that every problem is going to have a mean, a standard deviation, an x value, and a z-score. So with every problem that we ever do, you should be able to identify 3 out of 4 of those items, and then you solve for the 4th. Okay? You should be able to identify 3 out of 4 of those items, and then you can solve for the 4th. Well, this whole page has got a mean of 63.6 and a standard deviation of 2.5. So let's look at each problem and find what the x and the z is for each one of these problems. Okay, so we know the mean, we know the standard deviation. We're going to find either x or z. One of those is given to us. X or z is given to us. Let's read what they give us. The Travis County chapter wants to take women who are taller than 1.75 standard deviations above the mean. So what is this 1.75? Is it a piece of data or is it a z-score? Good, it's a z-score. Why? Because a z-score is the number of standard deviations above the mean. Good. So 1.75 is that z-score. And we know our mean and we know our standard deviation. So now we can solve for the unknown height. And we can use our little fancy z-score formula where we say z equals x minus the mean over the standard deviation, x minus the mean over the standard deviation. And so then I can do my algebra there and solve for the height. Okay? I'm not going to go through that. We're just going to kind of set them up today, and then we'll do more of this solving tomorrow. All right, let's look and see how we can do this, how we can set this one up. The Austin chapter wants to take only women in the top 8%. So would this top 8% be giving me the x value? That's the data. That's the height. Or am I going to be able to get a z-score from that? Well, it's not a height, so I should be able to get a z-score from that. So there we go. There's you a clue. So it's not the height, so I'm going to get a z-score. So let's look at your z-chart, and let's kind of think about how in the world can I get a z-score from knowing that I need to be in the top 8%. So I'm wondering, what is that z-score right there with 8%, top 8%? Yes, this chart is not full of areas above. This chart is all full of areas below. So I need to find the area below that is 92%. So go find the area inside here. Find this area below that is 0.92, because you guys told me there's 92% below that z-score. Okay, let me see. Here we go. That's the closest one. So that is a z-score of 1.4. And go up and find the hundredths place right there. So this z-score with 8% above it is 1.41. Okay, very good. So let's go back to our problem and set this thing up. So I know my z-score, 1.41. So I'm going to set that up. 1.41 equals x minus the mean over the standard deviation. X minus the mean over the standard deviation. Okay, then I would do my algebra to solve for x. All right, last one. I want you to figure this one out. The Central Texas chapter wants to take women in the 88th percentile. So is this 88th percentile going to tell me a height, or is it going to get me a z-score? All right, so go to your z-chart and figure it out. Percentile is the area below. Either one of those is equally good. So you could pick 1.17 or 1.18. Okay, either one of those is fine. I'm going to be honest with you. When it falls smack dab in the middle, and I don't know which one to pick, which is closer to, I like to go ahead and pick the one in the middle, which would be 1.175. Okay, so I will take any of those three answers right there for the z-score that goes with that 88th percentile. The one that is most accurate is that one, but if you don't get how to do that, that's fine. Okay, very good. So now let's go to your assignment. If you'll turn to page 12. All right. So on this page 12, you're going to be doing just the first 11. That's just this first part. These are all on the standard normal curve where the mean, all of these here have got a mean of 0 and a standard deviation of 1. Okay, and so on. All right. So what you are going to do on all of these is draw your picture. Basically do what you did on the quick check, but for this set. So do numbers 1 through 11 today and do the drawings just like we did on the quick check.